So here's a problem from Unit 1, Lesson 4, word problems. I believe that this is part of the instruction video, but if you want a different way or a different method to approach this problem, this video is for you. So here's the question. Celeste rides her bike to work, averaging 12 miles per hour. On her way home, she averages 8 miles per hour. If the total trip takes 1 hour, how far does she live from her work? Okay. So first, I want you to notice that this is a rate times time and equals distance problem. So you might notice that even the title says it. The reason why I know is they mention miles per hour. Miles per hour is a rate. So here. So there's my rate. Here it mentions if the total trip takes 1 hour. So it's telling us that's the time. The time it takes Celeste to complete her trip. And then here's our last word. How far does she live from her work? So there's distance. So when you have rate, time, and distance, here's the formula. Rate times time is equal to distance. However, although we have one equation, we're actually calculating two different things. We're calculating when Celeste rides her bike to work. So that's the first scenario. And then it mentions that on her way home, she averages 8 miles per hour. So when she bikes to work, she bikes a little bit faster, 12 miles per hour. And then her second is when she bikes to work, bikes from work. And then you'll notice that Celeste, her speed is different for both situations. So I'm going to make a table, rate, time, distance table. So these are the two scenarios. I'm going to put rate, time, distance. This is my table. So I'm going to fill in everything that I know. So first, Celeste rides her bike to work averaging 12 miles per hour. That's a rate, so I know that 12 miles per hour is her rate. Bikes to work. On her way home, she averages 8 miles per hour. That's on her way back. That's 8 hours. If the total trip takes 1 hour, so here it's a little bit tricky because although we know that her total trip took 1 hour, I don't know exactly how long she took going to work and how long she took coming back. I just know in total is 1 hour. So let's say I made T the time that she took to work. Then that means whatever that time is, if I do 1 hour minus that time, that would be the time she rides her bike from work to home. So once again, I'm going to put T here because I don't know how long she took to work. But whatever this time is, if I subtract it from 1 hour, then that would be her time that she comes back home from work. You might wonder, but Miss O, we were able to figure out rate and time, but they don't mention anything about distance because that's what they want us to find. How far does she live from work? What's the distance? So we might feel a little bit stuck here, but if we reference back to our equation, rate times time is always equal to distance. I am going to multiply rate and time to obtain distance. So 12 times t is 12t. 8 times 1 minus t is 8 parentheses 1 minus t. So I use this equation, but you might realize, but Miss So, it's nice that I have something for this table, but I still don't know how far does she live from work. I still can't answer that question. So you'll notice even though her speed from home to work and from work to home is different, but the distance from home to work and work to home should be the same. So this distance and this distance, they must be the same. So since they must be the same, I'm going to represent that as an equation. 12t is equal to 8 times t. And I'm going to solve for t, because the moment I figure out what t is, I can get this t and substitute it into that t to figure out what my distance is. I can also plug it into this t, but you'll notice that the distance for this first slot might be a little bit easier to calculate than this slot. So let's solve for t. First, I'm going to use distributive property. So I could simplify the right side. And then I'm going to isolate t and make sure my variable t is all on one side of the equation. So I'm going to add 8t to both sides. Then I have 20t is equal to 8. Then I'm going to divide by 20. And I have time is equal to 8 over 20. You'll notice, I think I can simplify that. So a number that I can divide that goes into both 8 and 20 is 4. And I have 2 over 5. So there's my final answer for t, 2 over 5. So I'm going to get this t equals 2 over 5 and plug it into my distance. So once again, I'm going to use this 12t only because it looks like a little bit less work, more efficient than the second one. So I will plug this in here and substitute it. So my distance is 12t, and I'm going to substitute 2 over 5 into t. You'll notice I have a whole number and a fraction. This whole number, something you can't see, but it's the same thing as 12 divided by 1. You're going to multiply straight across, so it's 24 over 5. And then if you go back, our unit for distance is miles, because they told us in the rate is miles. So it's 24 divided by 5 miles. You might notice that no one really mentions miles as a fraction, so if you want to, you can change it to a decimal. It'll be 4 and 4/5, which is the same thing as 4.8 miles. So that's the distance from home to work, 4.8 miles, and then from work to home is also 4.8 miles.